we present the biogeneric copy mode. In this clinical case, the patient's major complaint was the reduced length of the teeth 11 and 21. The incisal of the teeth had become shorter. It was also observed that there was no incisal guidance, and in an old photograph it was noticed that originally the teeth 11 and 21 were longer. To solve the problem, we used the chairside equipment from Sirona, the CEREC-AC. We opted for the option biogeneric copy, and this requires literally copy the shape you want to achieve. Thus, the length of each tooth was increased by composite resin, followed by review and approval by the patient. The upper arc was then scanned for a file folder called biogeneric copy. The crowns were then removed and the remaining teeth re-prepared. To allow good digital molding, the retractor cords number 000 and 1 were inserted for gingival retraction. While the retraction cords make effect, the lower jaw and intermaxillary registration were scanned up. The obtained files were attached to specific folders in the software. In this case, the software InLab 4.0 from Sirona was used. After the required time for gingival retraction, the superficial cord was removed and the deeper maintained. The surfaces were opaque with spray and a digital impression of the upper arc obtained. The used scanner was the Blue Cam that works with confocal microscopy principles and makes multiple photos and combine it into 3D model. So, each outlet needs at least 30% of the previous photo. The models are generated by the program and displayed on the screen for virtual articulator mounting. Other camera models like the CAD-CAM iTero, the Tree-Shape Trios, and Sirona OmniCam don't need any powder to get the digital model. To mount the models on the virtual articulator, the software drags the image of the bike registration to the upper model, so the images become coincident. The same is done to the lower virtual model. After mounting, it has the option to occlude and disocclude digital models. Latest software, such as the Sirona InLab 4.2, even allow exclusive jaw movement. These software are very interactive and ask for the next step with a red light or activating an arrow. The following steps were positioning the model in a virtual arc and positioning the planes respecting the midline, trimming the die, and delineation of cervical margins. Then is requested you to mark the outline of the tooth that is going to be copied. The tools that are used in these most different design softwares. In this case, by clicking the left button and dragging the lines according to the interest. We move it to a special moment that you give the command which generates the tooth in question. At this time, the software was programmed to search on the library the most similar tooth to the provided proposed copy. At this point, through drawing tools, you can change the shape, add, remove, and smooth the surface, among others. In this case, it copied, including roughness present in the resin copy, making us rethink about the finishing and polishing of the resin copy. In the sequence, the same steps were followed to generate the other tooth. After two teeth were ready, They were still sent to the CAD software to a virtual block, which simulates the real block, made of glass ceramics, where they will be milled. The work will now go into CAM equipment, the manufacturing part. Thus, the block is placed inside the machine, which reads from the conference plant and mills one and then the other block. These machining operations, depending on the size of the tooth in question, varies from 8 to 15 minutes. The crowns were then adjusted in the mouth and definitely fixed after glaze. The final result, in about 3.5 hours, very pleased the patient that had resolved the original complaint. So we saw obtaining crowns by the biogeneric copy technique.